Hey y'all, in this video we're going to go over how to construct an acceleration time graph from a velocity time graph. So first let's go over the steps for doing this. The first step you're going to do is calculate the slope of your line for each segment in the graph, right? So the slope is the rate of which the rate of acceleration for the object when you're dealing with velocity time graphs. The slope formula is simply stated as rise over run, or you can get the more formal version of it of y2 minus y1 divided by x2 minus x1, right? Your second step then when creating your acceleration graph is to draw a horizontal line on that graph for the same time period using the slope to determine where to place your horizontal line along your y-axis. So let's help this make sense with a few examples. So if you're following along on the guided note sheet, I went ahead and filled in the graphs on the left. Yours on the guided note sheet are blank, so I would just draw them to match. So our first graph here has a diagonal line that goes from 0 to 10 on our y-axis and goes for 5 seconds. I don't have units labeled, but we're going to deal with meters per second and seconds. All right, forgive my errors in not having units. All right, so first step was to find your slope. Your slope is rise over run. So we're going from 0 up to 10. So our rise is a positive 10. And our run goes from 0 to 5. So that's going over 5. So it's 10 divided by 5, which is equal to 2. So our acceleration is going to be 2 meters per second squared. All right. So on your acceleration time graph, you're going to go for the same time segment. So we're going to go for 5 seconds. And we are going to place that horizontal line at a positive 2 for those 5 seconds. All right, that's all you got to do is place that horizontal line with whatever the slope is where that line goes. All right, in our next example, we have a horizontal line at 5 meters per second, and it goes for 4 seconds. So you technically don't even have to do rise over run because you're a smart person and you know that a horizontal line is equal to a slope of 0, okay? Just to confirm that mathematically, our rise starts at 5 and ends at 5, so your rise is 0, and then your run is 4. When you solve that, you're going to get 0 because 4 can't go into 0 at all. So anyway, your acceleration time graph is going to go for 4 seconds, and your slope is 0, so your horizontal line will go at 0 for those 4 seconds. All right, is that not too bad? All right, let's get slightly more complicated with some two-part graphs. So now we have, for the third graph, we start at 4 and drop down to 0 for 2 seconds, and then we keep a horizontal line for the next 2 seconds. So we're going to find slope for each section. So the first section here, let me highlight it. Your first section is that diagonal line, and then we'll switch over and do that section second. All right. So the first section, your slope, your rise goes from 4 down to 0. So that would be a negative 4. And that occurs for 2 seconds. So your run is 2. So negative 4 divided by 2 is negative 2. So your first slope is negative 2. Then your second section, like we just talked about, is a horizontal line. So your second section, your slope is 0. Now for your acceleration time graph, you're going to have 2 sections to this. The first 2 seconds and then the last 2 seconds. So the first 2 have a negative 2 slope. So your line is going to be at negative 2. Then your second 2 seconds are at 0. So that line is going to be at 0. And then you just put a little dash vertical line to connect the two. Okay? Sound good? All right, let's do the last one and we'll be done with this video. So now we have another 2-part section graph. We could have tons of parts, but we're going to keep it simple. We could, on your test, you'll see probably graphs with like 5 different sections to them. So we're going to break this into 2 sections. We're going to find the first diagonal and then switch over and find the second diagonal. All right, so for the first one, your rise goes from 0 down to negative 4. So again, your rise is going to be negative 4. And that's going to occur for 2 seconds. So your slope here is negative 2. All right. Then for the next one, you're going from negative 4 up to 0. So this time your rise is a positive 4. And it's going from 2 to 4 seconds. So your run would be positive 2. And your slope is a positive 2. So now, again, you're going to keep the time segments the same. So 2 to 4 seconds. You're going to have the first 2 seconds marked at negative 2. Let me move that over a little bit. And then the last 2 seconds from 2 to 4 is going to be at a positive 2. And again, you just connect those with a dash line. It's a terrible looking dash line, but you get the idea. So again, you find the slopes for each part separately and then plot those horizontal lines at that slope. So again, all you're doing is finding slope and then marking the horizontal line for where the slope is. Right? If you've got any questions on how to do this, please reach out and let me know.